So just to let you know, I am recording here, but please stop me if you see that I make any mistakes. I typed up this paper in an attempt to get a full lesson on the quadratic formula from the beginning. Very simple stuff to the more advanced situations we get in with the quadratic formula. So I want to begin. We're going to do this in two videos. The first video is going to be on simplifying and applying the quadratic formula just like on one or two equations. And the other one will be specifically on several equations with the quadratic formula. Right here on the opener, it says review of simplifying roots. And yes, you could use a calculator if you want, but sometimes there's calculators missing and you might not have one. So if you don't have a calculator, you're going to have your perfect square number list. And it'd be a good idea to jot it down right now. 1 times itself is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. And it continues forever. Now, why would I want to write down this perfect square number list? In case you don't have a calculator, you're going to need it to simplify square roots. You see, the square root symbol actually tells you, or it actually asks you, what number times itself gives you this answer 16. And of course, the answer is 4. Okay. The reality is the square root of any one of these perfect square numbers is a nice perfect answer. The square root of 9 is 3. Square root of 64 is 8. Square root of 144 is 12. Square root of 121 is 11. So when you have the square root of one of these perfect square numbers, it's a beautiful answer. And 1 through 4 are all perfect square numbers. You should be able to answer them very easily. What times what is 16? The square root of 16 is 4. The square root of 49 is 7. That's right. Square root of 144? 12. The square root of 81? 9. Super easy, right? Now, how about this one? The square root of 50? Well, what the heck? 50 is not up here. There's a 25, 36, 49. It's close to 49, but 50 is not a perfect square number. So whenever you don't have a perfect square number, you're going to rewrite this number with multiplication to get one of these perfect square numbers. So you just got to ask yourself, if it's possible even, start with the first perfect square number, like let's say 4. 4 times what gets you 50? It doesn't work. You move on to the next perfect square number, 9. 9 times what gets you 50? It doesn't work. 16 times something give you 50? No. 25 times something? Yes. 25 times 2 gives you 50. So you could rewrite 50 as 25 times 2, and then you could split the root. So now you have a square root of a perfect square number. You didn't have a perfect square number, but now that you rewrote it with multiplication, now you do have a perfect square number. So the square root of 25, that's the nice, beautiful answer, 5, no more square root. And the square root of 2 stays the square root of 2. And that is your answer. Any questions? Simple, right? Now, the next one, 12. 12 is not a perfect square number. So you want to think of multiplication, so you could rewrite it with multiplication to get one of these perfect square numbers. So obviously 4 times 3 is 12. So 12 was not a perfect square, but when you rewrite it as 4 times 3, and then you split the root, now you do have a perfect square. You have the square root of 4. That's a beautiful answer, 2. And what about the square root of 3? Can't do it, just bring it down. That's as simple as it gets. Okay, so always try to rewrite it with multiplication. And again, the whole purpose of rewriting it with multiplication is to get one of these perfect square numbers. So 26, this is not a perfect square number. I wish it were 25. The square root of 25 is 5, but it's 26. So it's not up here, but could I rewrite this with multiplication to get one of these numbers? Well, if you think about 26, what times what is 26? 2 times 13, but 2's not up here, 13's not up here, so that doesn't help you. And that's it. You can't really rewrite 26 with any other numbers besides 2 times 13. So if you can't rewrite it with multiplication to get one of these numbers, that must mean it's already simplified. So you just leave it the same, okay? It stays square root of 26. It's like me saying, go ahead and reduce the fraction 3/4. Well, 3/4 is already reduced. You can't really reduce it further. That'd be a different story if it was 3/9. 3/9 could be reduced by 3, but 3/4, you can't do anything else. It's already simple. So right here, the square root of 26, there's nothing else to do. It's the square root of 26, okay? And by the way, if you're like, man, I'm already losing it, I don't get this stuff, you could use a calculator. Let's look at number 8 right here. It says the square root of 28. As you could see, you could type it into the calculator. All you got to do is hit this square root button right there, and then type in 28, hit equal, and it'll do it for you. The answer is 2 squared to 7. Again, the process that if you didn't have a calculator, you'd be like, well, 28 is not a perfect square number. Could I rewrite it with multiplication to get a perfect square number? Yeah, 4 times 7 is 28. And if you split the root, you can now do the square root of 4, which is 2, and the square root of 7 stays. That's how you get 2 squared to 7. But the calculator does it for you. So 2 squared to 7 is the answer to number 8. 2 squared to 7. So yes, you could use a calculator. Now, I think I've talked about negative numbers before, the square root of negative numbers. Those are not real answers because remember, the square root symbol itself is asking what number times itself is negative 25. So the answer cannot be 5 because 5 times 5 is positive 25. And it can't even be negative 5 because negative 5 times negative 5 is also positive 25, not negative 25. The bottom line is you cannot get a real answer when you do the square root of negative 25. Let's try it on the calculator. Type in the square root of negative 25 on a calculator, hit equal, it'll say math error because the calculator cannot understand imaginary values, right? What do I mean by imaginary values? You see, the reality is this, the square root of negative 1, that's really the variable I. It's imaginary. It doesn't exist. Like I said, what number times itself gives you negative 25? There is no real number times itself that'll give you negative 25. So here's what we're going to do. Whenever you see a negative on the inside of a square root, you're going to take that negative and you're going to move it out and you're going to write it as the letter I. And then you really will have I with the square root of positive 25 now. And now you could actually do the square root of positive 25. Square root of positive 25 is 5. And 5 times I is exactly that, 5i. It's like saying x times 5 is 5x. Right here, I times 5 is 5i. And there's your answer, okay? So whenever you have the square root of negative numbers, it's no real answer, but in Algebra 2, specifically, we're gonna really hit imaginary values a lot harder than Algebra 1. But right now, I want you to just understand that whenever you have a negative sign on the inside of the root, you gotta get that negative sign and move it out. Put the I out here, then you'll have I times the square root of positive 20, it's no longer a negative 20, and now the calculator could do this, all right? So pull out that I, now you could do this on the calculator. If you type it in on the calculator, it'll give you 2 square root of 5, okay? Now, there is the times I out in front, so it's just a question of reorganizing it. Put your nice number first, the 2, then put your letter I, and then put the square root of 5 at the very end. So this is the correct way to organize your answer, 2i square root of 5. Moving on to number 11. Okay, number 11, hold on a sec. We have the square root of negative 33, and right off the bat, you should pull out the negative sign, make an I on the outside, so you really have I times the square root of positive 33 now. And now on the calculator, you could type in the square root of positive 33, hit equal, and if you did do that on the calculator, type in the square root of 33, and you hit equal, it'll give you the same exact thing, square root of 33. In other words, it's already simple. It's like me asking you to reduce 1/2. It's already 1/2. You can't reduce it. So the square root of 33 is already simplified. So this is your answer, I square root of 33. Even if you didn't do it on the calculator, even if you tried to rewrite this with multiplication, it would be 3 times 11, and 3 is not a perfect square, and 11 is not a perfect square. So that is your answer, I square root of 33. That's your answer right there. Moving on, number 12, you're going to take that negative sign and move it out. Put the I out there. You're going to have I times the square root of positive 72 now, and now the calculator could do that. But if you want to do it by hand, you could do that as well. 72 is not a perfect square number. You could rewrite it with multiplication to get a perfect square number, like 4 times a pretty big number, or even better, use your highest perfect square number, which would be 36 times 2. So if you rewrote 72 as 36 times 2, and then split the root, then you'd have 6 square root of 2. So if you were to type this in on the calculator, it'll give you the answer 6 square root of 2. I just showed my work over here if you wanted to do it by hand. What about the I? The I comes down, so you're going to simply place that I in between the 6 and the square root. So you're going to have 6i square root of 2, and that is your answer. I hope all of this makes sense. We are now able to move on, but before we continue, I'd like to analyze this math problem. 4 plus 6 divided by 2. We all know that 4 plus 6 is 10, and 10 divided by 2 is 5. We know this, right? This is the correct math. to do. 4 plus 6 is 10. 10 divided by 2 is 5. But I want you to look at this question and do it in a slightly different manner. What manner? Check it out. I have some space here. Everybody, please follow along. When you're looking at this, instead of going 4 plus 6, let's recognize that 4, 6, and 2 are all divisible by a certain value, in this case, 2. So it's kind of like reducing the fraction. You're going to see that we're going to get the same answer, 5. But I'm going to reduce by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. 2 divided by 2 is 1. So if you divide every single number by 2, you're going to end up with 2 plus 3 on top over 1. And then 2 plus 3 is 5. And 5 divided by 1 is just 5. So we get the same answer, 5. It's just a different way of looking at it. Now, you might be thinking, why the heck do I want to cancel things out when I already know 4 plus 6 is 10 and 10 divided by 2 is 5. I'm going to stick to the original method. Well, that's fine. But the reason why we're doing this is because sometimes when solving quadratic equations, many times when solving quadratic equations with the quadratic formula, you may end up with these situations. Like this will be your answer, but you still need to reduce it. It's like having the fraction 5/10, and you're not going to find 5/10 on the multiple choice answer because 5/10 could be reduced to 1/2. So right here, this is your answer, but you have to reduce your answer. And you're going to look at all three terms, and you're simply going to divide all of them by 2 in this case. So negative 2 divided by 2 is negative 1. 2 divided by 2 is 1. And 2 divided by 2 is 1. Now, if you're thinking, what about the square root? Well, this 2 is telling you that you got 2 of these square roots of 5. But since you canceled it out, now you only have 1 of these square roots of 5. You treat it like if it were an x. But anyway, you got 1 of these square roots of 5s, and you don't really need the 1 in front of the square root of 5. If there's only a square root of 5, that means that there's 1 square root of 5. So far, your answer looks like this: negative 1 plus or minus 1 square root of 5 divided by 1. But we all know that dividing by 1 doesn't change anything. So like if you had an answer that your answer was 7 divided by 1, you're not going to write it as 7 divided by 1. You're going to write it as 7. You're not going to put the divided by 1. So right here, same deal. The simplest answer you could get is negative 1 plus or minus. This 1 right here is not even necessary because if you show the square root of 5, you assume that there's only 1 of those square roots of 5. And obviously dividing by 1 is not necessary either. So this is your answer. That's what you're going to see on a multiple choice option. So even though this is the correct answer, you have to reduce. And then if it's over 1, don't write it over 1. Just leave it like that. I hope that makes sense. Let's take a look at number 14. What could I reduce these 3 terms by? By what? By 2. I think it's also important to note that it has to be all 3 terms. Like if you had a 4, a 8, and let's say a 4, a 3, and a 6, and the 3 and the 6 could cancel out, but they all have to be divisible by 3, or they all have to be divisible by 2. So they have to be all 3 terms divisible by something. So right here, we're all dividing by 2. 4 divided by 2 is 2. 8 divided by 2 is 4. 6 divided by 2 is 3. And there's our final answer. 2 plus or minus 4 square root of 7 over 3. Oh, yeah. I guess I've been assuming that you guys already know that the square root of 7, you can't really do it, right? It's not the square root of 9. If it were the square root of 9, you'd get 3, and 3 times 8 is 24, and you could continue the math. But square root of 7, you can't simplify it. That's as simple as it gets. You can't do anything else with it. That's why we leave it like that. Moving on to this next one. They're all divisible by what? By 7. Okay, so divide by 7, you're going to get a negative 3. Divide by 7, you're going to get a 1. Divide by 7, you're going to get a 2. And another thing important to say is that this square root of 10, you can't really simplify it. Even if you thought, oh, I could change that to 2 times 5, neither of those are perfect square numbers. Or if you type this in on the calculator, the square root of 10, and you hit equal, it'll give you the square root of 10 because it's already simplified. So this is our final answer. We got a negative 3 plus or minus 1 square root of 10, which means you don't have to put the 1 in front of it, all divided by 2. There's your final answer, okay? And this will happen on the majority of the quadratic equations that we solve with the quadratic formula. At the very end, you're going to have to simplify in this manner. Number 16. So number 16, right now you're thinking, well, I could cancel out that 2 and that 2. No, you can't because there's a 1 right here. It has to be all 3 terms. So you should check and see if you could rewrite this in simplified form. You could type it in on a calculator and it'll give you 2 square root of 5. Or you could do it by hand. What times what is 20, where one of them is a perfect square number. The perfect square number 4 times 5. Split the root. you'll get 2 square root of 5. That's how we got this answer here. That replaces the square root of 20. So now we have negative 2 plus or minus 2 square root of 5 over 2. And all three terms could be divided by 2. So divide by 2, you get a negative 1. Divide by 2, you get a 1. Divide by 2, you get a 1. So your final answer is the negative 1, the plus or minus. You don't need this 1 square root of 5. You just write square root of 5. And you don't need the divided by 1. You just leave it like that. And there is your answer. Let's do a couple of more of these that require simplification on the square root. Take a look at number 17 here. Well, you could do the square root of 12 on the calculator. Again, you can't cancel right now. Like if you're thinking, oh, 6, 9, and 12, they're all divisible by 3. You can't mess with the square root. That's like if it were the letter X, right? You can't mess with this. You could simplify this and then see if you get a nice number out here that you could reduce, and that's what we're going to do. So the square root of 12, it's not a perfect square number. I want to rewrite it with multiplication to get a perfect square number. 2 times 6 does not help us because neither of them are perfect square numbers. But 4 times 3, that'll do it. Square root of 4 is 2, and the square root of 3 stays. So this is going to replace the square root of 12. So I really have negative 6 plus or minus 2 square roots of 3, all divided by 9. And now we ask ourselves, could we cancel all these 3 out? Could we reduce by 2? Well, I could reduce that by 2 and that by 2, but this I can't. Well, could I reduce by 3? Well, this I could reduce by 3. This I could reduce by 3, but this I can't. So what does that mean? That this is the answer. Remember, it has to be all 3 terms to be reduced by a certain value, okay? Not just 2 of the 3. It has to be all 3 terms. So that is your answer. I hope this is making sense. Number 18, if you start with the radical, you're going to remember that the negative sign has to come out and it becomes an I. So you're going to have I times the square root of 50, and now the calculator could do the square root of 50 for you, right? Or by hand, give me a perfect square number that times something else will give you 50. Well, 25 is a perfect square number times 2, that'll give you 50. And if you split them, you can now do the square root of 25, that's 5, and the square root of 2 stays the square root of 2. And what about the I out in the front? The I out in the front comes down, and you have I times 5 times the square root of 2. All you have to do is rewrite it, 5I with the square root of 2 at the very end. Now keep in mind that this is the same thing as the square root of negative 50. So all we're going to do is replace them. Negative 15 plus or minus 5I square root of 2. And that is all over 10. And now we have 1, 2, 3 terms, and they are all divisible by 5. So we're going to reduce by 5. Negative 15 reduced by 5 is negative 3. 5 divided by 5 is 1. And 10 divided by 5 is 2. So our final answer is going to be a negative 3 plus or minus 1I square root of 2. But you're not going to write the 1. You're just going to write I square root of 2. And then on the bottom, we have the 2. And there's your final answer for number 18. I know I've been teaching fast. I apologize. I hope this makes sense. Again, why did we practice reducing, simplifying? Because at the very last step of our quadratic formula that we're going to be doing right now, we may have to simplify the way we did right here on 13 through 18. So now that we've practiced those simplifying skills, let's move on to applying the quadratic formula. Now, here are the steps written out for you. There is a step 0 before even beginning the quadratic formula. Before beginning, you got to make sure that it's in standard form. Standard form is ax squared plus bx plus c equals 0, right? Or it could be in the form of a function, like a parabola, y equals ax squared plus bx plus c. But you have to have ax squared plus bx plus c all on one side. That's the only way you're going to identify a, b, and c. And once you identify a, b, and c, then you plug in the a's right there, the b's right there, and the c right there. Now, the first step, once it's already equal to 0, or once you have it in standard form with the y equals, you replace the formula. I should have written variables, the formula variables with parentheses. So instead of writing the formula, you rewrite it, but with parentheses. And then you plug in the values, the a value, the b value, and the c value, you plug it into the parentheses. And then from there, you simplify it, but you simplify the discriminant first, the b squared minus 4ac. It says plug in the values and begin by finding the discriminant. This value inside the square root is called the discriminant. And it's b squared minus 4ac. After you do that, once you get if you do all this math, you do something squared minus 4 times something times something. Let's say you get a 25. Then you rewrite the square root, but with the 25 instead, and then you actually do the square root of 25. So you simplify the square root, and if it were the square root of 25, you get 5, and then you reduce the entire fraction if possible, right? So it's kind of hard if you don't see it in action. Let's actually use these steps on this first problem, and I rewrote the formula right there for you, and I even rewrote it with parentheses so you could get used to that, plugging it in with parentheses. Now, if you just start saying, oh, my A value is 1, my B value is 8, my C value is negative 13, it's going to be wrong, okay? Because you got to remember step 0, make sure it's equal to 0, right? Make sure it's equal to 0, or make sure you have Y equals that stuff. And right here, it's equal to negative 13. That's not good. So let's start by moving that 13 over by adding 13 and adding 13. Everybody, please follow along. Now, our new quadratic trinomial equation that will be set equal to 0 is x squared plus 8x plus 13 equals 0. And now you could identify that the A value is 1, the B value is 8, and the C value is 13. And now that you know the A, the B, and the C, you simply plug it into the formula. With parentheses though, right? If you don't put parentheses, it's very likely you're going to make a mistake. Even if you use a calculator without the parentheses, it's going to come out wrong. So we're going to put the B values, the 8 goes right here and right here, okay? The A values, the A value of 1 goes there, and the C value of 13 goes right there at the very end, okay? Now, on the instructions on the bottom left, it says start with the discriminant. You want to start with this value right here, 8 squared in parentheses minus 4 times 1 times 13, of course, in parentheses. So you could do it with the calculator, or you could do it by hand. By hand, you would start by saying, okay, what's 8 squared? It's 64, and you would probably write that somewhere on the side, 64, just to keep track. And then what is 4 times 1 times 13? 4 times 1 times 13 is actually 52, but with the minus sign in front of it. So you're going to have 64 minus 52, and 64 minus 52 is 12. So the discriminant value, the value inside the square root, is 12. But you could do it on the calculator. Let me show you. And there it is. Your answer is 12. Type it in exactly the way it looks. The discriminant is the value inside the root. The value inside the root. Don't type in the square root, right? Just type in the inside of the square root, get an actual answer. Sometimes that answer might be negative, which is going to produce imaginary values. Sometimes that answer might be 0, right? Sometimes it might be a perfect square number. Right here, it's just the number 12, which is not a perfect square number. But anyways, let's continue. We have a negative 8 plus or minus the square root of, we said that we got 12 on the inside. We got it by hand, or on the calculator, we got 12 in there. And it is over 2 times 1, which is 2. So the question now becomes, what is the square root of 12? You could do that by hand, or you could do it with the calculator. As you can see, the calculator tells us that the square root of 12 is 2 square root of 3. So what we're going to do is simply replace the square root of 12 with 2 square root of 3. So you have negative 8 plus or minus 2 square root of 3 over 2, right? All we did was replace the square root of 12 with 2 square root of 3. After that, we could reduce the fraction. That's what we were practicing just a couple of minutes ago. We have 3 terms, 8, 2, and 2. We could reduce all of them by 2. So 8 divided by 2, negative 8 divided by 2 is negative 4. 2 divided by 2 is 1. 2 divided by 2 is 1. So what's our final answer going to be? It's going to be a negative 4 plus or minus. You don't need the 1, but you do need the square root of 3. So negative 4 plus or minus square root of 3, and you don't need the divided by 1. So here's your final answer, negative 4 plus or minus the square root of 3. Ta-da! Final answer right there. Okay, so we're gonna stop. We're gonna end this video right here. I just hope that we understand these steps on how to solve using the quadratic formula. Step 1, make sure it's set equal to 0, or have y by itself. And then you could identify your A, your B, and your C, plug it into your formula with parentheses instead of the letters. And then you start with the discriminant, the b squared minus 4ac, and then you'll have a number, and then hopefully you could simplify that square root, and then you reduce the fraction, okay? On the next video, we'll pick up right here doing questions 2, 3, and 4, all with the quadratic formula.